Hi, everyone. Welcome to my past summit session, Extending Your Use of Extended Events. My name is Erin Stellato. Thank you so much for showing up today. I know there's a ton of great sessions going on right now, so I'm really happy to have you here. As I said, my name is Erin Stellato. I'm a principal consultant with SQL Skills, and make time this week to explore all of the options here within the PASS Summit. So there's a ton of things for you to check out within the site. And I will also give you a quick reminder here that before we're done today, if you could submit a session evaluation. I know we haven't even really started talking yet, but I want to throw that out there. I'll remind you again, but these are great things for not just speakers, but also for the event organizers as well. Little bit about me. If you haven't heard me speak before, this is my Yay Me slide. The most important thing on this slide is my email address, erin@sqlskills.com. If you have a question today, first of all, I strongly encourage you to ask it. And if you haven't attended a session yet, or if you've been in a couple sessions, I just want to remind you that you've got two panels. You have a question panel and you have a discussion panel. So discussion kind of for chatter and that sort of thing. Any questions you have specific to this session, please put in questions. Now, to be fair, if you saw the keynote this morning, you'll know that I mentioned Oreos. Okay. And I did bring them. If you want to talk about Oreos or have questions, that's going to go in discussion. Okay. But questions about extended events stuff, please throw in the questions tab. And I'll be monitoring that throughout the session. Again, email address on here, most important. You can always ask questions on Twitter, but if it doesn't fit in whatever the character limit is these days, send me an email. I am a consultant. I've been a consultant for SQL Skills for over 8 years now. I do a lot of speaking. I do training for our immersion events. I'm a data platform MVP. And I put this slide in here about the SQL Skills team because sometimes in a session, I will reference my team members, Paul, Kimberly, Jonathan, Tim. And I want you to kind of have a frame of reference for who they are. So they're up here on the screen. We offer, in addition to training, we offer consulting services. If you're interested in any of those things, please check out our site, sqlskills.com. We revamped it earlier this year. It looks fantastic. Take a look. And again, if you have questions, just send me an email. So I put the abstract for this session on a slide. I'm not going to read it to you, but I do want to point out a couple of things before we get started. One, this is not an intro session. I have an intro session that I have done tons of times on migrating to extended events or using extended events for the first time if you are a profiler or a trace user. This is not that session. This is a session that's a 300 level that assumes you have used extended events, that you have some comfort level with it, and you're ready to do more. Very often, when people start with extended events, they have transitioned over to it and start doing the exact same things in extended events that they used to do in Profiler. And I'm going to show you how to go beyond that because there's so much more to extended events. It is not just a replacement for Profiler. It is a whole different way to think about troubleshooting. And so to start, what I want to do is revisit basically the order of events is not the right term in this actual session. The way that things happen when you have an extended event session running. So let's assume that we have an event session that we've set up for something that's very common where we want to track completed statements, whether it's an SP statement completed or a SQL statement completed. We want to capture those events that have more than 500,000 reads. Okay. So we're filtering on 500,000 reads. So what happens is first there's a check to see, is this event enabled, right? So when that event, that point of interest, the statement completed is encountered in SQL Server, if is enabled equals true, then we're going to continue on in collection mode. That means is enabled equals true, means that some event session is capturing this event. So we move on in collection mode, which means get the payload data. If you remember, every single event in extended events has what's called a default payload, a set of elements that are there by default when the event fires. So it's going to go grab that payload data immediately. Then it goes to predicate evaluation, right? So in our case, we have a predicate, we have a filter of where reads greater than 500,000. Excellent. If the predicate evaluates to true, then we're going to publish the event. So the event fires essentially in the context of the extended events collection. If we have any actions for our event or events, it's going to go collect those at that time. And then if we are writing to a synchronous target, like the event counter, it's going to serve that data up to the synchronous target immediately. Or what's more frequently happening is that you're serving events to, or you're writing to an event file, or maybe you're using a different target like the histogram, and those are asynchronous. So for asynchronous targets, what happens is all that event information goes into a set of intermediate buffers, and it sits there until the buffers fill up or until the dispatch latency is hit. And the default for that dispatch latency is 30 seconds. And then at that point, it gets pushed out to the target. So what we're focusing on today here is the predicate. We're going to talk about predicates. We are going to talk about actions, and we are going to talk about targets. So we're going to break these down and look at them in more detail as each different component within that greater event session. So the predicate, as I've said already before, right, this is the filter. This determines whether or not that event is going to fire, whether we're going to capture it. And I'm going to strongly recommend that you always have predicates on your events, because very often, depending on your workload, if you do not have a predicate, the event session can overwhelm your environment. Now, extended events is much more efficient than trace, but you can still create a poor event session that wreaks havoc on your system. So predicates are the first place to start. And when you create those predicates, when you set those up, you can set those up on that default payload data, right? Any of those elements that are available when that event fires, or you can use global predicate source fields. So these are fields that are not necessarily part of that default payload that you can use as a filter. An example for statement completed would be something like database ID. That's not part of the default payload, but it's a global predicate source that you can still filter on. And what's interesting, and I mentioned database ID specifically because when you're looking at the default payload, those elements, the names there, they can be the same. When you're looking at the global predicate source fields, the names there can be the same as actions, which we're going to talk about, but they are two different entities. So database ID is a global predicate source, and database ID is also an action. But a global predicate source and an action are two different entities entirely, even though they will have the same name. And I know that's a detail, but it's an important distinction that at this level of XE, I want to make sure you understand. It's also critical that you're aware of the fact that if you filter on something that's not part of the default payload, there's extra work there. SQL Server has to go and get that field in order to do predicate evaluation. And if you filter on fields that are not part of the default payload at all, like let's say you filter on 4 fields, it has to go get all of those to do that predicate evaluation. So I'm not saying that you have to always just filter on the default payload, but this is something that's fundamentally different than trace. And so I want you to understand that this is a point where you can unintentionally introduce a little bit of overhead. Now, predicates are really, really cool in extended events, and this is another place where they shine and are beyond anything we could have ever done in trace, in that you can do not just an equal to or a greater than or a less than, but you can do things like greater than last value or divides evenly by a number. And an example of the divides evenly, like when would you want to use that? Let's say that you kind of just wanted to collect a sample of data and you started your event session and you're thinking, well, how am I just going to do a sample rather than everything? Well, you could sample based on session ID. You could divide session ID. If it divides evenly by 2, so all the even ones, then retrieve that session ID. If it divides evenly by 5, right, grab that one. So that's a way to kind of do a sampling. This type of predicate configuration, never available before. And you also have the ability for the predicate to store a state, which means how many times has it fired, and only publish it every that many times. So as another example for sampling, I could say only publish it every 5 times to get a random sample that way. And there's one more thing. Oh, inverse predicates. So I can still do a not equal to, a not in, etc. I'm going to pause for a second because there's a question which I forgot to mention in the beginning, so my bad, with regard to the slide deck and the scripts. So hang on, because I want to show you something, and then I'm going to make a link available as well. And again, my bad for not saying this in the very beginning. I even had a note to do that. This is where you can get the script and the deck right now. So it's on GitHub, and I'll put this, maybe I'll just drop this into the discussion. I think I can do that. You know what? I don't know how to do that, but Simon is my moderator, and Simon's fantastic, and Simon will make that available. So this is, if you just do GitHub Erin Stellato, you should find it. You're going to look for the summit 2020.zip file. That's where you can get the script and the deck. Okay, back to our regular scheduled program. So these are our options that we have for our predicates. And when we do predicate evaluation, I tend to script out my event session so that I can look at the predicates in T-SQL, because we can have multiple logical blocks that SQL Server is going to step through, and these are denoted with parentheses. So you know how when somebody writes a really crazy where clause in a query and you're like, oh, I got to format this to understand what's going on. Same thing with our predicates and extended events. I will very often script this out so that I can see what's going on, because it is not intuitive to me in the UI. I smile because I love this. I love that with predicates, it supports this concept of short circuit evaluation. And what that means is the first time a predicate evaluates to false, it basically stops. It prevents further evaluation. And this is very powerful, but it also means you've got to be really careful when you're writing your predicates. So when you do an and, right? Database ID equals 5 and logical reads greater than 500,000. The first block that's false says we don't need to go on, because it's an and scenario, right? They both have to be true. So if the first one isn't true, there's no need to go to the second one. This is different than an or. An or scenario says any one of these is true, right? So if I have database IDs 5 or logical reads greater than 5,000 or duration greater than 1 second, then it's whatever one it hits that is true, it kicks out. It's done. It doesn't need to evaluate anymore because one of those has already evaluated to true. So we're done. So to give you a visual of this, right, you need to think about the order here. So this predicate says where database ID equals 5 and duration greater than 1 second. I know that looks like a million, but this is microseconds. So greater than 1 second, and logical reads greater than 500,000. Now, if you think about this, right, and I'm going to go crazy with my arrows here, it's going to, and let's make an assumption. Let's say that we have multiple databases on this instance, but database ID 5, that's my busiest database. I have tons of queries coming into this database. I don't have a lot of queries that go over 1 second. I don't have a lot of queries that have greater than 500,000 reads. So the way that this is written is going to be, is database ID equal to 5? No, it is. It is. Is database ID equal to 5? Yes. Is duration greater than 1 second? No. Then we're done. Is database ID equals to 5? Yes. Is duration greater than 1 second? No. Then we're done. Do you see how this is inefficient? Database ID greater equal 5? Yes. Duration greater than a second? Yes. Logical reads greater than 500,000? No. Right? So if database ID 5 is our busiest database, I don't want database ID 5 to be first because it has to continue through the logic every time and I'm wasting CPU cycles. What I would rather do is put logical reads greater than 500,000 first. This is way more unique. So the key is when you write your predicates with an and, whatever is most unique, whatever is going to fail the fastest is what I put first. So logical reads greater than 500,000? Nope, I'm done. Logical reads greater than 500,000? Nope, I'm done. Greater than 500,000? No, I'm done. Greater than 500,000? Yes. Greater than a second? Yes. Database ID 5? Yes. That meets predicate evaluation. Okay, so this is important when we're talking about our and scenario. It's also important for or. So again, in this first case here, we're saying logical reads and duration and database ID, right? These all have to be true. In an or scenario, logical reads greater than 500,000 or duration greater than a second or database ID equals 5. Any one of these can be true. But because any one of these can be true, because it's an or scenario, if I put logical reads first, and that's not common, then it's going to keep rolling through. So the better way to write the bottom block is here, right? We're going to put database ID first, because if database ID evaluates to true, it's done. It doesn't care about the duration. It doesn't care about the reads because it's an or scenario. So your predicates, really cool, really powerful. Pay attention to how you write them. And I mentioned logical blocks, and thus far we've been working with one logical block. This is where it gets more interesting, right? Here we have where is system equals 0. That's our first predicate. Then we have an and then we have our second predicate marked by I'm doing it wrong. There we go. The parentheses, right? So my parentheses denote that second predicate. And then within that second predicate, I have another or, which means I have a nested predicate in there with another nested predicate at the bottom. So in the UI, this is really difficult to read. When you have to get to writing more complex predicates like what you see here, I really recommend that you script that out in T-SQL so that you can view it in Management Studio. Now, enough of slides. Let's take a look at what I'm talking about. So I'm running SQL 2019. This is cumulative update 7, which was one that was pulled. Cumulative update 8 is out now, but I didn't want to risk making this change right before a session. So there's no issues with this CU for what I'm doing in any way, shape, or form. So we're going to work with a stored procedure and a function that is in the AdventureWorks 2019 database. And I'm not going to go through this in great detail. It's a horrible function. I can't take credit for writing it. Jonathan wrote it. He can write some really horrible code when he wants to. It's a gift. I'm grateful for it. And the reason that I am doing this demo is because there have been a ton of improvements in Tempdb over the years. If those of you that worked with SQL Server back in the 2000 days probably remember when that original KB article came out about Tempdb and concurrency and creating multiple files, right? So 20 years and change, we've been fighting Tempdb, and there have been a ton of great changes that have improved things. But depending on what version you're running, you may not have access to those. And I know that there are workloads today that can still create contention in Tempdb. And this right here is one of them. And if you want to look at contention in Tempdb, the old way prior to extended events was to use the DMVs, where you were looking at DM OS waiting tasks and looking to see what queries were waiting that had a wait type like a page latch that were specifically against Tempdb, right? The 2 denotes the database ID, Tempdb. And then we can do some interesting manipulation up here where we're looking at the actual page IDs to figure out, is the contention PFS contention? Is it GAM? Is it SGAM? contention. But the challenge with using this method is that you had to continually query it, right? Or you had to set up an agent job that queried it and snapshotted it to a table and then go back and look at that. And that's a lot of work. And extended events makes this significantly easier. So we'll set this up and then we'll run the code. We're going to make sure that our session doesn't exist. And I do this in T-SQL for a couple reasons. One reason is you can see this predicate much easier. The other is that it's much faster for me to create this with T-SQL than in the UI. That said, I almost always create every event session in the UI. I don't have this T-SQL memorized. I don't expect that anybody else does. But for demos and for sometimes looking at what's actually happening, it's a little bit easier with the T-SQL. So we're creating our event session. We are adding the latch suspend end event. This is the only event that I'm going to add. And we are filtering here first on database ID equals 2. And then we're going to say duration greater than 0. So we're waiting for some amount of time. And our mode is going to be our lock mode. This is an update or a shared mode. Or maybe, I think it's a shared. And then it has waiters, so it has something behind it waiting. And then we're looking at the specific page IDs. So in our, let me open this up and let's look at this just side by side for a second. Right over here, as part of our select, we did a little bit of math, and here we've done the math to identify the actual page IDs in question, right? Whether it's a page ID or a GAM page. And notice this is a case where I can use this divides by. So I'm dividing the page ID by 8088. Every 8088th page is a PFS page in a file. And the same for the GAM pages, 511,232. And then we've got our SGAMs just hard coded here. So this is an example of a complex predicate, right? Database ID, duration, and then we've got an and in here, and we've got another and another and then a bunch of ors in here. So all of my ands have to be true, and then any one of my ors. We're going to write to the event file target just for history, but we're also going to utilize the histogram target, which I'll come back to a little bit later on. And then we'll go ahead and start that event session. So let's create this and start it up. And then what I'm going to do is we're going to go to extended events. And within my session, if I refresh this, we will see that it's running. And I'm going to open up the histogram target right here. And then I'm going to fire up my workload. So my workload calls this client. So this Tempdb client here is basically this horrible function stored procedure that we created, which has some horrible functions in it. And this run Tempdb client just calls to that SQL file. This is just uses SQL command to call that up. And then we're going to do that. Well, we're going to do it a lot. We're going to start with 10, but we're going to add more because again, they keep making some improvements here in SQL Server, and sometimes it gets harder and harder to create the bad demo. So we're going to fire up, we'll start with 30 clients and see what we get. And then our refresh interval for our histogram, we're going to set this. And you can see we've already got some data in here. Now on the DMV side, let me query. And we get data here as well. We happen to catch it, right? So we can see that we've got page latch updates waiting here and shared also. And this is on Tempdb, database ID 2, file ID 1, page 2, which is a GAM page. And over here with extended events, right, this is just going to continue to refresh as the problem continues to occur. Whereas on the DMV side, I'd have to query this, and I can still catch it. That's great. But I can't always, right? If this is an intermittent problem I'm having with Tempdb, with my DMV query, I may or may not grab it. Here with my extended events, I can see that. And again, this value here, this 2, this is the page ID. I'm also getting the raw data. So if I wanted to look at the event file target, I could use that as well and get all of the raw data in here. But again, this histogram target, which I'll come back to, does the aggregation for me, which makes my life a lot easier. Okay, if you've got questions about this demo, throw them in. There is a little bit of a delay between when I'm showing you something and when it's getting to you. So if I seem a little bit behind at any point, that's likely why. I'm going to see what questions I've got right now while waiting to see if you all have any other ones. So this one is, if I use a global field in my predicate and have a same name action, will the filter use the global or the action retrieved value? So this is an interesting question, Jonathan. So again, there are two different entities, so it can't use one for the other. So if you have a predicate, which is a global predicate source, so let's say database ID, and you also want to capture database ID as an action, then it filters using the global predicate source. And then after predicate evaluation, if you remember the order of events, after predicate evaluation, then it will go collect the actions. So two different entities, and you can't basically cross use them for anything. Vlad says, are there any huge differences from SQL Server 2017 to 2019 extended events? A lot of the differences that you see now per release are the events. Every time there's a new feature or every time a feature is expanded upon, there's additional events available in the system, and those become available through extended events. So if you look at the number of events from 2012 to 2014 to 2016, 2017, 2019, it goes up from like 600 in 2012 to we're over 1,800, I think it is, in 2019. So that is huge. So that's typically what I see. What I'm hopeful will happen down the road is we've asked for an additional target related to service broker. I don't know if that will make it in there. That would be a significant change. It's not in there at this time. So again, right now, most of the changes are really related to the events that are available. Lee has a question about the histogram target. And this is like kind of the chicken and egg thing. I had to talk about that, even though I haven't talked about that yet. So Lee, I'm going to come back to targets, I promise. And we'll talk about that in a little more detail. All right, I'm going to close this up for the moment. And again, if you think of a question later, feel free to throw it in there. We'll have time at the end. I can come back and I can set up things again. It's not a problem at all. Let me minimize this. Grab a drink of water. Again, hopefully you've got whatever beverage, cookies you need at this point in your day. So now I want to move on to actions. Again, global predicate source actions are two different things entirely, even though sometimes you'll see them with the same name. So an action is an additional operation that we want SQL Server to do. It's additional, something else we want it to collect or to capture. So database ID is one example I've been using. Session ID is another. And there's more advanced options like creating a mini dump for the thread or creating a dump entirely, and also doing a debug. So we tend to think of actions most frequently as event fields that are interesting to us that we want to collect as part of our output. But it can do advanced things as well. And again, the actions are only going to fire after predicate evaluation occurs. So only if it evaluates to true are we going to go and collect any of those actions. And one of the things about your actions is that they're going to be available to you, but at the time that in terms of configuration, but at the time that the event fires, the state data might not be available. Let me give you an example. Think about statement starting. We always talk about statement completed events, right? And how we want to look at those. But sometimes you do a statement starting and you do a statement completed. And if you do a statement started and you did as an action, I'm trying to think of a good example here, duration. You couldn't really do that, but let's say it was duration. You wouldn't have duration. You wouldn't have state data for duration at statement starting. Okay, so if you ever add an action and you're not getting any data for it, it might be because when that event fires, that state data isn't available to it. Now, there's an important thing to understand about your actions, which goes back to performance. So similar to considering using global predicate source fields for your predicate, I also want you to think about what actions you add, because as part of the life cycle with extended events, the actions execute on the same thread that fired the event. So let me give you a picture of that. Remember, we started with this, is event enabled? If so, true. So are we capturing statement completed? We are. Go collect the payload data, perform predicate evaluation, publish the event, execute actions, go get that data. All of those steps are on the same thread that fired the event to begin with. And when I say fired the event to begin with, I mean, if I wrote the query, if I executed the stored procedure, right? And I'm the one that fires the batch completed event or the statement completed event, all of this has to happen, predicate evaluation, payload data, actions, on the same thread that I'm waiting on. So when I put tons and tons of actions on there, then that potentially degrades performance because it has to go get all of that information. I'm not saying don't use actions. I'm saying use actions wisely, right? Only use them when they are adding benefit to the event data, when you're going to use them in your analysis. I try not to just grab things because, oh, that might be interesting, or I wonder what that is, right? If I'm truly considering the performance impact of my session, I want to pay attention to what actions I'm adding. And try not to use your actions to do event correlation. Back in the days of Profiler and Trace, very often you would add session ID and transaction ID, and you try to figure out what query executed in what order. You don't have to do that in extended events. You have this great session option called track causality. Use that instead because it attaches a GUID and a sequence number to your events so you can see what happened in what order. And these actions can cause side effects. So I mentioned the three big ones, right? Performing memory dump, whether it's a single thread or all the threads, and then inserting a debug break. Those are significant. So those cause a side effect, and those are on the same thread. So if you ask your event session to perform a memory dump when a particular event fires, then whatever thread fired that event has to wait until that is finished before it continues. Okay. If you want to play with those, that's what your test, your dev environment is for. I have never actually used a debug break, and I would recommend that you only do those memory dump actions, probably at the request of product support, or if you're really comfortable with memory dumps and you know what you're doing with those. But potentially can be very great in terms of troubleshooting and problem solving, but there's overhead there. So let's take a look at our actions. We'll go back to our demo. I tend to spend most of my time in the demos because I'm a visual person and I like to see what's going on. But sometimes you got to set stuff up, right? Okay. Let's make sure that I have a recent copy of Wide World Importers restored here. So we're going to get that going. And let me set up this scenario. How many of you have stored procedures that are nested, and they call another stored procedure, and then they call another stored procedure in that, and then maybe they call another stored procedure or a function in there, and trying to understand what happened in what order is just excruciating. I get that. I've been there. I've got a scenario like that now, and it's a challenge for sure. And we're going to walk through a case where we want to understand a function and where it's being called, because we're trying to understand where it's coming from. And rather than search through all the code, we're going to rely on extended events to tell us. So we're going to work backwards here. Okay. So rather than going this way from the top procedure and then in and then in and then in, we're going to start at the bottom and we're going to build backwards here as we go through the code. So our function is going to be called returns true. And it just returns this text, basically to say that this function was called by third. So that's what this function does, really simple, right? I know it's not that simple in your world, but humor me. This is our last procedure in the nested call, which is called third. And so here, this depends on the input value. So if the input is 100, then we're just going to return text that says third was called, just returns text. But if we put in anything else besides 100, we're going to call that function, that returns true function, which will spit out the text of function called by third. So we'll create that procedure. Then we've got a second procedure, which is just called second, and it calls the third procedure with the value of 1. So with our logic, when it calls third with the value of 1, it's going to come in here and it's going to run that function, which is then going to return the text of function called by third. And there's no input here for called second. So we can call it easily from called first. I know it's a lot, right? This is not uncommon. So we have first, second, third function is our nesting order. And then just for fun, because this also happens, right? We have another procedure called other procedure, which first calls third with a value of 100. So the function will not be called. And then it calls it with a value of 1. So it will be called. So we have a couple different ways to get these functions called. Now, how are we going to track this with extended events? This is the beauty of our actions. So let's make sure that we have our object ID for that returns true function, because I'm going to need that as part of my filter. And let's make sure that I don't have this event session in place already. Now, let's drop this object ID in and then we'll walk through this. So we're creating our event session, which is called T-SQL Stack. And the event that we're adding here is module start. And module start is the same as what you would have known as SP starting. So when we've got a procedure, a function, a trigger starting execution, this module start will fire. So I've got this, and then I've added one action, right? My action here is T-SQL Stack. Now, T-SQL Stack is an expensive action, and the overhead of this is not insignificant. So I want to make sure that my filter is good here, right? Because remember, predicate evaluation happens before we get the action. So my module start, and then my filter is where object ID is the ID for my function. So only when this function gets called should this fire. And in this case, I'm just going to write this to the ring buffer target. Again, we'll go over targets in more detail. And we'll start up our event session. And then again, we are going to watch that live. So Tempdb contention, I will stop just because I don't need that right now. But for my T-SQL stack, I'm going to show you this target data. It's not really that exciting. And I don't have anything of value in here at this point, which is totally fine. So we are going to, actually, you know what? I don't want to watch this. Let's look at the live data viewer. This will make it more interesting. Here we go. So the live data is just what's flowing in to my event session, different than my target, right? This basically gives us that profiler-like view that we were used to in our early days. So we're going to execute called first, which should call second, call third, call the function. So we'll run this and we'll see function called by third. Now, sometimes it takes a minute, not quite a minute, for information to show up here. That's normal. Doesn't mean anything's not working. So I can see here this T-SQL stack. I can see that, let me zoom in here. Here we go. I can see that this is my returns true function, right? Object type FN. And I've got my stack down here. All of these other things here are my default payload, everything except T-SQL stack. T-SQL stack is my action. You'll notice that the statement is empty here. I've drawn all over it, but trust me, it's empty, right? You can't rely on statement here to give us what we're looking for. That's why we have to add the stack. And when I double click on this, this is a bunch of stuff that I'm like, what am I going to do with? I have the X query for you. To be fair, I didn't write it. Jonathan wrote it. So this is it. And I don't love the ring buffer target because you have to write Xquery to parse it, but there's a lot of good Xquery already out there. So don't let that completely dissuade you from using it. But here's what we're going to do. we are going to pull this information out. And you'll notice that just with this first query, all I'm doing is I'm getting the same output that I just clicked on before in my live data viewer window. We can do better. We're going to break down the stack. So this is the code that really pulls this apart in more detail. So now we can see the event ID. We can see the level within this T-SQL stack. We have a handle, which is going to be valuable, along with offsets. So if I really want to see the query, I'm going to take this handle and I'm going to cross apply that over to DM exec SQL text. The catch here, here's what you have to understand. In order for the output here to be successful, the information still has to be in cache, right? Because DM exec SQL text is a DMV, dynamic management view. The data in there is not persisted. So if I'm going to query this data, this ring buffer data, and join over to DM exec SQL text, what I'm querying, the handle that I'm querying, still has to be sitting in cache. And it is. And what happens here is if we scroll over to the right, now I can see all of my calls. So I can see the originating object as well as the statement it executed. So this works. I'm going to scroll to the left for a second. My highest level is where I started. My lowest level is where I ended. So with level 4, right, we start with called first, which called second, called second, called third. Called third with a value of 1, select returns true, and returns true is our function. So this allows me to walk through here to figure out what's going on. Now, just for fun, let's call third 100. So we're just going to run that, which just returns the text, right? And so this will show up here. It won't show up on the right side, and nothing's going to show up in here because that doesn't call my function, right? So only if that function is called are we going to see the output. So now if I call other procedure, which called third with 100 and then called third with another value, we will see it show up in our output here, right? Third was called returns text, function called by third. It pops in over here. And when I rerun this giant query one more time, I now have event 2, right? So a whole nother set of information, right? Event 1 was that first execution where we started with our high level function. In this case, when I called my other procedure, right here, then it called third, and then it called my function returns true. Okay, so the stack is really cool in that it lets you unwind all of the statements in a module that happened before it that called it. So you can find that nested scenario that is so sometimes dreadful to try and troubleshoot. The key there is filtering on that function, the ID that we're looking for. I'm going to go ahead and stop that event session. I'm going to leave it in place just in case we need to come back to it for any reason whatsoever. All right, so now I'm going to move on to targets. I'm going to grab some water and also just kind of pause, see if I have any other questions coming in. So Venkata has a question about using extended events for replay. I'll come back to that one at the end. I'm just going to stay on this track for a moment with actions and then moving on to targets. But now I'm going to get to Lee's question, which is what is this histogram target? And the thing to understand about your targets is that those are what consume your event. So again, very used to writing to the event file, right? That event file target stores our events, it persists. But we have other options with extended events which allow us to do different types of troubleshooting. A target is either synchronous or asynchronous. Synchronous means that target gets fed on the same thread that fires it. So It's a more expensive target if it's synchronous. Asynchronous means it goes to those intermediate buffers and then it gets dispatched out to the target. Targets can either grab the raw data or it can do aggregation for us. What's important to note here is that when you have the raw data, you can still do your own aggregation in the UI. These aggregate targets are helpful because they will help you analyze that data faster, potentially, because they're doing some of the work for you. So they can be really advantageous when troubleshooting. I also want to point out that you can create an event session with more than one target. So we're used to, with extended events, just writing out to an event file, or sorry, with trace, just writing out to an event file. With extended events, I can have an event session that writes out to the event file, but also has the histogram target, like we did for the Tempdb demo. I have a summary here. This is a lot. I'm not expecting you to memorize this, right? But this is just kind of a summary of the different targets that you have available and what kind of data you get and where this data lives. I'm going to go through this in a little bit more detail, but I'm just introducing you, right? We have the event counter, we have the ring buffer, we have the event file, the histogram, and then event pairing. So many more options than we had in previous days. So the event counter target is just how many times did the event fire? It's a synchronous target. It's a memory resident target. And you might think, why in the heck do I care about how many times an event fires? And the most useful case for this is when you don't understand a workload and you want to get an idea of how frequently something fires before you run that event session in production when you're actually writing out to an event file target. It's also a really good way to kind of test out your predicates and see if those are correct before actually running everything and capturing the data as well. So this is a good, let me understand what's going on before I get too far in type of setup. The ring buffer target is an in-memory target, and you specify how much space you want to consume in that ring buffer in memory, right? It's a memory resident target. And let's say that we allocate 4 megs to it. And 4 megs, it's a first in, first out queue. So if I start pushing events and they start going into the ring buffer target and my ring buffer target fills up, when it gets to the bottom, right, the events that came in first are going to be ejected, and so that new events can come in there. So the ring buffer target's a finite amount of space where the data does not necessarily persist. It's kind of like a temp storage that'll just roll over. So if you want to keep data, this is not the target for you, right? This is where you can lose events or you don't capture everything, and that's okay. A couple of things that are important to note. That data is in binary format, but you can materialize it as XML, which means you have to write XQuery in order to read it. There's a lot of good XQuery already out there. You don't necessarily have to reinvent the wheel. If you're a developer, you'll be like, I'm all over this, maybe. You might like that. There is one challenge with this target. It can only materialize up to 4 megs of data. So if your ring buffer target, let's say you set its size to 16 megs, and it's filled with data, it can only materialize 4 megs of that. So it is not an ideal target for larger data sets, or if you think you're going to have a larger data set, you probably also want to do the event file target so that you've got that raw data in another persisted location. And because it's a memory resident target, when you stop the event session, your data is lost. So I tend to very often, anytime I'm using any memory resident target, I also use the event file target because this information gets written to file on disk and it persists after the event session is stopped so that I can do analysis. I can share it with my friends. I can, push it into a table just like you could before. You can still take files, you can push it into a table and do your analysis that way. It has the same schema as the ring buffer target, and you can actually read it using the fnxe file target read file function, but you can view it in Management Studio. So this to me was the game changer for extended events. When I had to try to read data from the file in the 2008 days. Like I was like, no way, like I don't want to write that X query. But in 2012, all of a sudden everything worked in Management Studio, and 95% of my analysis for extended events is done in the Management Studio UI. Now, the histogram target is another memory resident target. It doesn't collect all the raw data. This is an aggregate target. And with the histogram target, what happens here is that you specify a field that you want to bucket on, that you want to group on, that's going to create a histogram, right? Not to get confused with statistics in any way. But let's say that we wanted to understand what database had the most activity, had the most statements against it. So we could have statement completed, and we could do the histogram target, and we could bucket based on database ID. We could do the same thing for object ID. It doesn't store the event data itself. It just gives you a counter. So with the Tempdb demo, we were bucketing on the page. So for page ID 2, we had a count of how many times that latch suspend end event fired for that particular page. So it's a quick way to do an analysis. But if you want to keep anything long term, you also want to write to probably the event file target. And then the last one that I want to mention is, this one's really cool. It's the event pairing target, also a memory resident target. It's a form of an aggregate target. And what it does is it matches events based on criteria that you specify, and it discards the matched pairs. So event pairing means if it doesn't match, let me see it. It's easiest really to view this in the UI. You can query it. It's got the same structure as the ring buffer, right? But you've got to write that X query. So the UI to me is the easiest way to look at that output. But again, it's memory resident. So when the event session stops, that data is going to go away. What you really have to be careful of here is what you are matching on. So as an example, let's say that you wanted to understand something about locks, and you did lock acquired and lock released, and you matched them based on session ID. And the thing is there's not always a one-to-one relationship there, because you can have something like lock escalation, and your lock fired and your lock releases are going to be way out of whack, but it's not actually indicative of a problem. So you really have to understand the events and kind of in some ways how SQL Server works, and then what you really want to match on. And if you are having trouble figuring out what you need to match on, track causality is your friend. This is an event session option. I mentioned it before. It adds a GUID and sequence number to your event, so you can kind of see what happened in what order. And I do that with the event file target. It's the easiest way to look at that data. So since that's the trickier one, we're going to use that for our demo. So let's open up pair matching, and we're going to set up this environment. So we have a procedure, and let me actually drop this into another window so you can see it a little bit better. So we'll make sure that that procedure doesn't exist. That's what we have first here. And then we can pass in a value here, a time value, and it's 50 milliseconds to start. And basically we're in this stored procedure, all we're doing is we're running a select, and then we have a wait for delay based on whatever we input. By default, it's really, really short. So it's nothing too crazy here. So let me execute that. And then I'll close this window, and we're going to create our event session. So let me make sure that one does not already exist. So here's our event session. We're going to call it SP statement timeouts. We're going to add statement starting, and we're going to add statement completed. And you'll notice that we have a fair number of actions here. This is an expensive session. I'll tell you that right now. I wouldn't recommend this on a high volume system, particularly because I didn't put any predicates on here. So this is really a horrible example for production. Sometimes with timeouts, you kind of have to make it worse before it gets better. This is a decent amount of overhead. So I'm getting session ID, I'm getting the T-SQL stack, which again, I told you is expensive. I'm getting SQL text, and I'm also getting plan handle. And for statement completed, I'm getting session ID and I'm getting T-SQL stack as well. Now, our pair matching. We are adding the target of pair matching, and we're specifying a begin event, which is our SP statement starting. And we specify an end event, our SP statement completed. And then we specify what we match on. So we are not just matching on session ID, we're also matching on T-SQL stack, because session ID isn't enough to guarantee we have the right begin and end. So we're going to put the T-SQL stack in there, which again, that's a lot to pull down and then also to match on. I'm going to also add my event file as a target here. So let's create this event session. And we'll start it up. And I should fix this so that we have the right database in there. And I'm going to purposefully make this fail. So you'll notice we're going to run this 10 times standard. Then we're going to run it one time with a 5-second delay. And we're going to run it 10 times again standard. And to make it fail, we're going to change our connection properties. So we're going to go into our options, and we're going to change our execution timeout to 2 seconds. So this one is going to fail. And we want to make sure that we are watching this live. So statement timeouts, and we are going to view that data, and let's view it this way. I never look at the data this way. Let's do that. So we already have some stuff in here, but this is related to extended events that's going on. It's not related to any query we've executed. So let's go ahead and run this. So it's going to run 10 times, it's going to fail, and then it's going to run 10 more times. And we can see down at the bottom, right? We can see here, query completed with errors. It shows up right there. And then if we scroll down a little bit, we have execution timeout expired. Now let's refresh our data here. There we go. We get a little bit more information in here. So let's see what we get. We get a select from sales order detail. Let me zoom in over here. We get select from sales order detail. We get another select from sales order detail. And we also get a wait for delay. So the thing is that statement executes really quickly, right? So why am I seeing this in here twice? And this is where, when you're troubleshooting, you might want to go to the raw data and look at that. So let me bring the raw data back in here to this top screen. And let's see, I've got my statement, but let's see if I can scroll down and find what I want. I don't want to stop my session because I'll lose my in-memory data that we're looking at right there. And I don't want to get rid of that. But I want to find, here we go. So the thing about this is this has everything, right? Because I don't have a filter. So I can see here, right? Let's expand this out a little bit. I can see that I have a statement starting, statement completed, starting completed, starting. This is interesting. Starting again, completed, starting completed. So what we're not seeing is we're not seeing the completed case for either one in my output here. But let me go down a little bit further, and we keep seeing a match, and I'm looking here, right? This is the scenario where I have a starting and I don't have an ending. And remember, I told you to use track causality. So track causality right here gives all of these within here an activity ID, a GUID, and my sequence number. So what's interesting is that I have two statement startings for this select, and then I have a completed. And then I have a statement starting for my wait for, but I don't have a completed. So what I really expect to see in my output is just in my output for my pair matching, it's just that wait for delay that times out. But I'm also confused. Why do I have two statement startings? And this is a tricky one. This is because I don't know if you noticed this. I was kind of rude and I didn't totally point it out to you. But back here, I threw a recompile onto that select. So it executes and then it actually executes again because of that recompile. So this event session was flawed from the beginning on purpose. So if you thought you were missing something, you weren't. Those are the types of things that you have to investigate to understand what's going on. So what I'm going to do is we'll stop this event session in this format because this isn't the format that I want, and we're going to fix it. So we're not changing our procedure at all. I'll drop that event session. And this time when we create it here, right here is my statement starting. I have all of the same actions, but now I'm going to add a predicate of where state equals 0, which means do not fire my recompile events. Everything else, I'm still going to leave exactly the same. So let's run that. And then start up my event session. And we'll bring in, let's refresh this. And we'll look at this here. And I'm going to stick with this horizontal tab. I never tried it. I like it. And let me fix this. I always do the vertical. But for this, it's nicer to see the whole thing in the bottom. And let's make sure that I change my connection timeout here. Because again, I'm in a different window. Let's change that to 2. Connect. Run this. So I'll have, again, 10 successful executions, 1 failure, 10 successful. So here's my timeout. Let's refresh this output down here. And now I just have my 1 row in the output, which it tells me, right? Let me expand that out and then I'll zoom in so you can see it. Right? I can see the text here was executing that stored procedure with the value of 5 seconds. And then the statement, which had a started but not a completed, was my wait for delay because I was supposed to wait for 5 seconds. I set the connection to timeout after 2. So this is what returned. So this is an event session that's really helpful when you're troubleshooting timeout events. If you have a .NET application, right, the default timeout is 30 seconds. And sometimes there are things that take more than 30 seconds. And the user perhaps doesn't get a very informative message. And so in trace days, we would try to troubleshoot with the attention event. But here, we can use this start and end event combination along with session ID, T-SQL stack to understand what is the query that started that didn't finish. Okay, so I have some great questions in here, which I'm going to go through my key takeaways and then I'm going to come back to my questions because I have some great ones. And I have a feeling I'm going to hop back into some demos. So let me summarize real quick and then get to the questions. So a couple of things. The predicates, very powerful. You can write things that are really complex and interesting, almost to the point of pulling your hair out. So use that T-SQL and understand that you've got short circuiting to use to your advantage. So when you have that and scenario, right, what's going to make it kick out or fail first? When you have the or scenario, what's going to evaluate to true most often? Put that first. With your actions, additional information that can really help with troubleshooting. but only add what's important and be aware of the overhead. Some of these actions are more expensive. Targets are, right, how you're going to consume that data. Event file is your friend, but it is not your only option. A lot of these are memory resident. So remember that when you stop the event session, that data is going to go away, which is why the event file is a good second target to add. But they make that analysis easier and faster than sometimes writing everything to the event file and then taking a look at things. Okay, so I'm going to roll through some questions. Would T-SQL stack as an action be useful to identify where changes to a table came from? I would really, Gary, I would use audit for that instead, which audit actually uses extended events under the covers. Extended events became a full feature in 2012, and that it had complete parity with the events from Trace. But what they also did in 2012 was they took all of the audit events from Trace and moved those into the audit feature. But it still uses extended events under the cover. But I would, when you say where changes to a table, I don't know if you mean a schema change, like a DDL change, or if you mean a DML, data modification. I wouldn't use T-SQL stack for either one of those. Venkata, can we use extended events to capture and replay a production workload instead of profile or distributed replay? Yes, this is new. So distributed replay is still there, but distributed replay is now underneath DEA, Database Experimentation Assistant. And Database Experimentation Assistant does support extended events files. So you can use those now. You don't have to rely on Profiler and Trace. There's a couple people who have worked with DEA. John Starrett is one. Mindy Kernot has another. And there's probably a couple more that I'm forgetting, but Database Experimentation Assistant still uses DRU under the covers. Lee, hopefully I've answered your question about histograms. If I haven't, let me know. Jonathan, is there a good resource for learning about events and actions? There are a lot of them, my friend. I completely agree with you. So this is where the UI comes in handy, quite frankly. So I'm going to come in here. Let me refresh this to see where we are. I'm going to go into the T-SQL stack one, and I'm going to go on the properties. And this window takes a little bit to load sometimes because of the number of events, frankly, that are available right now. So with regard to events, I'm going to bring this up, and there is no comprehensive encyclopedia dictionary of every event and what it does. It's kind of built into the product. So Query Store is another one of my favorite features. And first of all, you have that search capability, which I love. But if I'm looking at events and I want to understand what's going on, you can highlight it. And there's a description here. This, a lot of times, is how I figure out what an event does and whether or not it's something that I want to use. So I start with searching for a term or a word that I'm interested in and what events match that. And then I'm looking at the description. For the actions, right? Let's throw this one over here. Let's go over to configure and look at my actions, right? This description of what these are is right here as well. So if I want to understand, right, what host name is, it's the name of the host name of the client, right? If I want to, database ID, all of these have many definitions. Is it comprehensive and thoroughly detailed with examples? It is not. Some of it honestly becomes a little bit of trial and error, which is why your demo systems are great, which is why using the event counter at first is probably a really good place to start. Jamie, if we want to know the values of parameters to the function, can an action be used for that? Actually, if you use RPC completed, that will normally give you the input values. You're not going to get that from an action. You're only going to get it from specific events. Keith said, do I have a reference for the list of predicates I can use for a specific extended event I want to track? So the predicates are here. And I don't have a list that documents what all of these are. So when you go into the event right here, and then you go into the filter and you drop this down, you will see what predicates are available. You will see those elements that are part of the default payload. So like I'm going to hop over here to event fields, right? And so in here, we have database ID and we have error count. That's the default payload for query store database out of space. For module start, we have a longer list, right? Line number, object ID, name, type, offset. So when you are highlighting this event and you go to filter and you drop this down, it's going to first list in that filter dropdown the default payload, and then it's going to list, starting here, package0.counter, all of the global predicate sources. When I go to query store database and I drop this down, I get my default payload at the beginning, right? Database ID error count here. Oh, that's a sad panda. That's going to go away soon. Bear with me. And then all of my global predicate sources beneath that. So that global predicate source list, global, right? They're available for all the events. Default payload, only going to be available for that event. Let me fire up Management Studio again. Marianne, can we use extended events to detect blocks that cause a timeout or a network issue? That's not what I would use there. You can see what query would have not completed because it was blocked, but you're not going to be able, the only thing you would be, no, I can't think of a good way to do that with extended events. I would, no. I have to think about how I would do that. I don't have a good answer for you at the moment. And I don't know that I would use extended events for that. If you want to send me a follow-up email, Marianne, I can ruminate on it. Yeah. Let's see. I don't know. You know what, Simon? I don't know how to move some of these that I've answered. So I think I answered Keith's question already here. I answered Jamie's. I've answered Marianne. So I'm going on down to Peter's. Can extended events track and gather more detailed info on server level, like TCP stack issues, disconnects? If the events are there, Peter, perhaps. But if it's happening outside of SQL Server, then no, because extended events is events of points of interest within SQL Server. So if something is happening outside of SQL Server, there's not an event for that. So extended events wouldn't be able to grab that, if that's what you mean by server level event. Jonathan, I think I answered that question about events and actions. Josh, if the asynchronous targets, if the server process stops or the event session is stopped, you potentially would not see some data. Correct, Josh. Oh, well, hang on. Let me answer. So an asynchronous target, it's going to depend. So if my asynchronous target is the event file, right? I'm writing out to the event file. Remember, for the asynchronous targets, the data goes into those intermediate buffers before it gets dispatched to the target. So if the event session stops, all of that information will be flushed to the target before everything goes away. So if I'm writing to an event file target, which is asynchronous, and I stop my event session, that information is going to be pushed out. If I'm writing to the ring buffer and I stop my event session, that data is gone. If I'm writing to the histogram, the event counter, pair matching, data is going to be gone because those are memory resident. If the server process stops, like there's a stack dump, it shuts down, correct. Even if it's the event file, it's likely, I've never tested it, it's likely that that information won't get flushed out, right? Because it's a hard or an unexpected shutdown. So then you may lose data in that scenario. But from stopping an event session, writing out to the event file async target, it would get flushed. Frank, is the order of predicates not violating what was said before about and clauses? Frank, I'm not sure I understand that question. Is the order of predicates not violating what was said before about and? Can you try to elaborate on that so that I can understand better? I don't want to make an assumption. Another question. If extended events are so cool and so powerful, why doesn't Microsoft make it easier to consume, use them? I think that actually they are easy to use. I think it's a matter of becoming familiar with extended events. I don't think that, I think the challenge is that Profiler has been around for so long. And I'm answering this question in the context of Profiler. Profiler has been around since 1997. Okay. It was released with SQL Server, 1998. It was released with SQL Server 7.0, which came out in November. Profiler is a legal drinking adult. It turns 22 this month. It's a tool that's been around forever that we have used for so long and we are so comfortable with. And so when we ask people to pivot away from their favorite movie and try and watch something new, right? There's resistance. And I get it. Like extended events in the beginning, I thought there's no way, this makes no sense to my brain. But eventually, once you spend a little bit of time with it, it does, right? If I come in here to extended events and I come into sessions, I right click, I come into new session, and creating an event session in here, let me just show you, right? So I'm going to track statements. I am going to do track causality. I want to look at my completed. So we're going to say statement completed. So we're going to add both SQL and SP statement completed. And then I'm going to come over here and I want to filter on duration greater than, I care about 2 seconds, right? And then my data storage, I'm going to write this out to an event file. I don't want it to go to the log folder. I actually want it to go to temp. I'm going to change this to be 56 megs. We'll keep up to 10 files. And I'm going to go ahead and say, okay. And that's created. And the beauty of extended events is that once you create the event session, like track statements that you like, maybe you have to tweak it a little to change the duration of the reads, but you can just leave it here, right? If I restart my instance, that event session persists between restarts. So on most production boxes that I work on, I have about 10 different event sessions that are there that I will stop and start as needed for troubleshooting. So I think honestly, it's a shift in, okay, this is what I know and what I've used for a long time, but this is extended events is here. And if you spend 30 minutes with it, honestly, trying to create an event session, like you can do it. It's just a different tool. Daniel, operators, difference between the equals and the equal ints. So let's look at that. Because again, visual person, I want to make sure that I understand what you're asking me. So let's look at statement completed and let's look at, we're going to do something that's highly illogical. We're going to say logical reads equals 100. And then we're going to say logical reads and we will drop this down and you are asking about this, and we're going to put that as the 200. Okay. And I'm going to say, okay. And then I'm going to script this out because this will help with our visual. Right. So here is this. And here is this. Oh, I did something great. I did what? Here we go. Greater than duration. There we go. Equal to with my logical reads. So I think what you're asking me is, do these function differently? No. I'll be honest in that I've never tested it. I always use this one. So this is an excellent question because I'm not 100% sure of the answer. So Daniel, if you'll do me a favor and send me an email, Erin@sqlskills.com, so that I can confirm And then once I know, I'll write a blog post and let everybody know. Great question. Alan, do I have any events that I install as part of every new server? Event sessions. I throw the pair matching one on there. I create an event session similar to track statements where I can change the filter. I also create one for wait infos. Wait infos, that's really not a term. It's almost 5 o'clock in my world. So some things that I do a lot when I'm troubleshooting is I might be running a store procedure or a bunch of code in a particular window in Management Studio. It's taking longer than I expect and I want to know why. So I set up an event session which has wait completed, and I filter on my session ID so that I only get my waits for my particular session. I could snapshot the DM session waiting, DM session waits with DM session wait stats. But I like this one better. And then I don't even write it out to a file. You don't have to have a target. I just leave it like that. And then if I'm in a different session, I just change the session ID and I run that. So those are a few that I tend to create. Santosh, what are the most commonly used extended events for performance tuning? Depends on what problem you're trying to solve. So am I looking at queries that execute frequently? Am I looking at queries that take too much resources? Depends on what resources those are. So that's kind of a wide open question. The completed events, batch completed, statement completed, RPC completed, those are probably where you want to start to understand what statements are using the most resources or executing most frequently. But again, there's more information I want to know before I would tell you to just go blindly create an event session like that. Josh, following up on your comment about creating and leaving event sessions. Oh, do I have any standards? Those are the ones I kind of just went through. My friend, Jess Borland. Hold on. I think there it is. You know what? She might have changed it. There she is. So Jess has a whole bunch of example event sessions here. And she has these are just like individual ones. She's got all of her session stuff too, but she has some other example sessions here that might be good. Again, the standard ones are usually like, let me track statement information, let me track some wait information, let me do pair matching. Those are 3 that I probably use most commonly. Deadlocks, sometimes I'll set up one separate for deadlocks, even though deadlocks are in system health. Depending on how often system health rolls over, I might want to separate those out. Michael, coolest trick that's only available in extended events that you don't have time to show here. Well, those 3 things I showed today are only available in extended events. So that's fun. No, there's, I might not remember all the details here. I probably won't. Jonathan might have it in a blog post, but this is, let's say that we have some type of non-procedure. It's a SQL statement completed that when it fires, it generates a stack dump. So we're going to come into here and we want to create the dump on that thread. And my filter in here is my counter. Pretty sure my counter, which is count the number of times evaluated. And I'm pretty sure we just do the 1, which means, and I say pretty sure because I haven't done this in a long time. And while I'm talking, let me see. let me see if Jonathan talks about this. But basically, here's the trick. The trick is that if you're going to add an action, a side effecting action like creating a dump, and you don't know how many times that whatever event is that causes it could happen. So you only want it to fire once, right? So if I remember, I think it's the counter, which basically says only do that on the first time. So that if that statement would occur again and it causes the problem, it won't create the dump again, if that makes sense. I'm probably not going to find what I want. So Jonathan has this fantastic set of posts here, which he did forever ago, and they're still useful. So he's got different, maybe it's this one. I'm not going to find it. I probably won't find it. If you want to know, feel free to send me an email. No, that's the customizable one. All right. Any other questions coming in? We've gone over, so hopefully y'all haven't left yet. Thank you for showing up. Let me hop back to my slides. If you've got any more questions, go ahead and drop those in. I think I had a couple other things I wanted to mention. I have some resources. What I talked about today does exist on Pluralsight. It's actually in Jonathan's advanced session. He talks through some of these things as well. But if you are not as familiar with extended events as you want to be, or you know people who are struggling to jump on that train, there's 2 introductory courses. John has one and I have one. We teach things differently, which is why they're both out there. And then I also have a SQL Server Central Stairway that goes through extended events as well. Jonathan has the 31 days of extended events, and I have a category for XE as well. Definitely a set of Microsoft documents. And thank you for being here. And please make sure to fill out the session evals. I mentioned that at the beginning. I want to remind you again, you have until, I think, the end of the week, but if you can do it while it's fresh in your mind, that's great. Again, the feedback is helpful, not just for me, but for past organizers. I'm always tweaking these presentations. If you download the session from Bits and the one that I did a couple weeks ago and this one, there's changes in all of them because I always think of how I can improve that. So feedback is great. I appreciate it. I appreciate you all showing up today. I think that I hit all of the questions. If not, please, again, send me an email, Erin@sqlskills.com. And if you're interested in Query Store, I will be talking about that more tomorrow. Jonathan wanted to see Jess's page again. So it's under her Twitter handle, which is Girl Geek with 2 R's. So GitHub, Girl Geek, Extended Events. And she's got a lot of great information samples out here. So I think that I'm hitting on 5 o'clock Eastern time. So some of you probably got to head to dinner. Some of you way in the East over in Europe and such are probably about ready to head to bed. So thanks for being here today. I appreciate it.